Hello. In this video we'll start talking about mathematical expressions in LaTeX. For that it's important for us to use, for example, mathematical packages such as AMS Math, which comes with a lot of mathematical environments and symbols and many other things that we might want to use. So now that we know sectioning, we can leave apart a section for other text that we want, and maybe we can start working on this section with mathematical expressions, something like that. And one of these very common environments that we need for mathematical expressions is equations. So we can begin and end equation. So we have inside here whatever is going to be in our expression. We can start with something very simple such as f equals ma. If we build this, we'll see here that the mathematical expression comes centered in the page and it comes numbered. On the right side of the page there's a number referring to this equation. We saw for sectioning that the numbers came up automatically, but in the left side, so for mathematical expressions it will come in the right. And we can start making more complex expressions. So for example, when we have a right triangle, we can say that c equals the square root of a square plus b square. And there are all sort of commands for these common mathematical functions, for example square root or sines and cosines and stuff like that. And if we don't remember some of these things, the nice thing about having a dedicated LaTeX editor is that there are some shortcuts around here. So you can see that there is a button here in TeXmaker for square root. If I click here, it will type for me the command for square root. And inside there we need a square plus b square, so we can write something like this. And this symbol here stands for superscript, right? So if we build this, we'll come up with an expression, and there's a square root that extends throughout everything that is inside the curly braces here. And the 2 comes as a superscript of a and as a superscript of b. So we have our a square plus b square. And we can have subscripts as well with underscore. So we can have another script, say I and d. They will come up nicely here, I and d. And you see that the square root sign encompasses everything inside it. The size of it is adjusted accordingly. And as you can see, the numbers come in sequence. If for some reason we decide that this equation now should come before the other one, the numbering will reflect the order that they were inserted in the text. So this one is equation 1, this now is equation 2. That's great. We can start building more complicated expressions such as using Greek letters. So this package here starts enabling us to use Greek letters, and for that we use slash and the name of the Greek letter. So we can say something alpha equals beta times gamma, and they come out nicely in the expression like that. We can have capital Greek letters as well, the ones that are not like the common Latin letters, so big alpha, it's just A, but the other ones we can just type the first letter in capital, they will come as a capital Greek letter, like that. And we can start combining things. So for example, we can say that me underscore x, or the mean of x, is the summation. There's another command for mathematical symbols, the symbol for summation. And we can just say that it is the sum of x index I. But it's not quite right yet, because we need something here to say, for example, where this summation begins and where it ends. And for that we use subscripts and superscripts as well. But now, as this subscript, for example, will be something I equals 1, there are many more characters here in this subscript, so we need to put all of them inside curly braces like that. And so everything that is in curly braces will be a subscript of the summation symbol. But it also has a superscript, so we can combine them, something like this. And now we have the summation from I equals 1 to n of xi. But that's still quite not right, the mean of x. We need a fraction here, we need to divide all that by n. And there's a command for fraction, so we have frac. And you see here that there are two arguments for this command. The first is the numerator, the second the denominator. So everything that we have here, the summation of xi, is the numerator, and the denominator is simply n, or something like that. And you see that the expression comes out like this. And the fraction command will try to adjust everything that is in it to fit inside the line without giving too much space before or after this line. We can have other types of symbols as well. So if we bring back this equation, we know in the notation of dots for derivatives that a equals v dot. So we have a command, for example, dot v, or the derivative of v related in respective to time. We can see something like that. So we can start combining all these different mathematical symbols and notations for our expressions. And we also know that acceleration is not just v dot, but it's also x double dot, and we can have d dot for double dot, and that will come as f equals mx double dot. But we also might want to write this in the notation of derivatives explicitly, expressing the derivatives. So we can say something like dx dt, second order derivative, and it will show up as something like this, right? If we want the partial derivative, there is a function for that as well, and it is the partial command. It's giving me an error here because I didn't put a space in there. So there you go. Derivative is d with a little turn to the left here. Partial derivative of the second order of x respective to t. So that's it. You can start building very complex mathematical expressions from these simple commands. And one of the nicest things of LaTeX is that they start looking really nice. All these mathematical expressions, as complicated as they might be, they come out looking quite well formatted for us.